In this video, we're going to talk about how to use Excel online for doing a two-sample means independent test. These are supplemental activities for an Introduction to Stats course where we use Excel, the online version, to do our exercises and learn the basic techniques for statistics. This assignment uses the cloud-based online Excel, not the desktop version, and there are a lot of differences. The assignment file is linked below should you desire to have a copy. Also, for BHCC students, this assignment for you is on Moodle. The purpose of this assignment is to perform a two-sample means independent group test. Our objectives are a two-sample means test using p-value and a two-sample means test with the confidence interval method. A two-sample means t-test is used to determine if there's a significant difference between the means of two independent groups. And that would be, for example, if we want to compare the difference between like men and women or like class A and class B. So the groups are not going to be dependent on each other. We're not doing repeated measures. We're doing two independent groups, which means the same person can't be like in both groups. And we're determining whether or not the average or mean from the two groups is different. And that is what this specific test is. Okay. So the test we're running is a two-sample means test of independent groups. The null hypothesis that we're testing is always going to be that the means are equal. That's standard for this type of test. What you're testing is that the mean or average of the first group is equal to the mean or average of the second group. Okay. The alternative to that is that the means are unequal. So you're testing that either your data supports this or your data supports this. That's what your hypothesis test here is about. There are a lot of other hypothesis tests. There's also other two-sample tests. We're not going to do those here. We're just going to do this test, which is really the most prominent. It's one of the most important hypothesis tests. So we're not going to do paired test or other test or test of not equal or test of like greater than less than. We're just going to do strictly the test of the two means being equal, which is the group means being equal versus the group means being not equal. Okay. So here is an example of how the data should be set up. Now, you probably will have to rearrange your data to do this test. And I'm going to show you how to do that in Excel because we want to have like group one in one column and then group two in the other column. These are not dependent. This is not like a before or after situation. And actually, but this is your two sample means test and you should have a label on them accordingly. Okay. So you might have to, and you very likely will have to restructure your data. If your data is like in a bigger data set, you're probably going to have to like pull your data out in order to run this test, like pull it out into like a separate column. So do be aware that there is that kind of like complexity here. It's not a super issue, but it's something to be aware of. Okay. So the traditional method for running this test involves computing a test statistic and looking at its associated area, which is known as the p-value. If you watch the assignment 11, that one is actually harder because for whatever reason, the one sample test is not automated in Excel with like a specific function. The two sample test actually does have like a function to run it. So it's actually easier than the one sample test to run. Okay. So in order to set this test up, we like to calculate. Now we're doing this for each sample, not overall. So we're going to calculate the mean of sample one, the mean of sample two, the data means, and then we're going to calculate the standard deviations. Even though we do have a formula that's going to run the test, we really want to have these for reference anyways. And then the count. Now, another thing to note is that they don't have to be exactly equal. They shouldn't be crazy off, but like it's okay if the number of samples you have in group one is not exactly the same as group two. Like you shouldn't have one sample here and 100 here, but if you have like 12 and then 15, that's fine. So it's not mandatory that the sample sizes are equal. Okay. So we do want to have these basic statistics calculated. And then what we want to do, another thing we want to do is determine if the variance is, the variance, remember, is the square root of the standard deviation squared is the variance, and then we take the square root as the standard deviation. But this measures variability. So what we don't want to have is we don't have like one group is not very variable and the other group is. Like this would be the distribution of like one group that is like really peaked and not spread out, and then the other group is really spread out. This rarely happens because you're looking at the mean of like the same thing, like measuring height or weight or whatever. It can happen though. So if this does happen, we just set the test differently to account for it. So we want to look at the variability of each group as measured by the standard deviation If these are like super egregiously off, we set the test to account for it. That's all there is to it. I mean, there's more to it at a higher level course, but for this course, that's it. So for this test, there's actually a function t-test, which runs array one. That's your first that's your sample one, your sample two. We are always going to be doing this as a two-tailed, which means not equal to. Um, and then the type of test, this is where this variation thing comes in. So if the standard deviations are similar, you're just going to use type 2. And if they're not, you're going to use type 3. Okay. And that's really the only subtlety of this. Okay. So let's go in Excel and actually run this test. Okay. So I'm in Excel. And again, I have the blue tabs for you, and then the yellow the blue tabs that we're going to go over now, and then the yellow tabs are your exercises. And yeah. So the first one is to determine if there's no weight between male and female genders. Well, this is sort of a mess. Or did I sort it? I think I sorted it. Okay. Um, hang on. Okay, so I fixed it. That's again, that's my like control thing. So yeah. There we go. So we have data on weight and then gender. Now, in order to run a two sample test, we have to work with this. So what I'm going to do is I'm going to click on both these columns. The first thing I'm going to do is actually sort by gender. So I'm going to go to data and I'm going to go to custom sort just because I like the detail of this. And then I'm going to do sort by column G. Always have my data that has headers checked off because otherwise it will make a mess. And then I'm going to go, okay. There we go. And now I'm going to have my gender sorted. Now, here's what I want to do. Let's create two columns. We're going to create F and M. Okay. And in F, I'm going to put the weight of the females, and that's going to be these values. And in M, I'm going to put the weight of the males. So I am copying, pasting, and doing some data rearranging here, which, yes, it's a bit of work. But this test is actually easier to run than the one sample, so we're good. So now I have the data in the format that I would like. I'm going to actually have to zoom out a little. Okay, that should work because I want to have enough space to write my summary stats down here. Okay. Actually, I don't have to write my summary stats down here. So, yeah, I kind of do. So I'm going to do the mean, the standard deviation, the sample size, and I'm going to do them down here. And so just so that they're below like their respective columns. And so this is going to be the average weight of the females. And that's going to be the average of these numbers here, which I'm flubbing to pick up correctly. Yeah, J2 to J36, perfect. Okay. And then the standard deviation, which is going to be the sample standard deviation of these. And then the sample size, which is going to be count of this. Oops. I don't think that's picking up correctly, so I'm going to redo it. Count. And then it's J3 to J33, I think. Yeah. Oh no, it's J3 to J36. Okay, let me just double check that these are right too. Yeah, J36. J36, perfect. Okay, so that's my mean standard deviation sample size for the females, 200, 134, and 34. And then I'm going to also carry this over here. Now that's going to give me the one for the males, and I don't have to like actually redo the formula because the little The teeny tiny little like magic candle thing does that for me. No, that's okay. So that kind of goofed up. I don't want to do that. I want to actually drag them over from the side because that one picked up means for everything. Yeah, there we go. Okay. Okay. So those are all my basic mean standard deviation summary statistics for the male and female. Okay. Now, let me actually let's see if we can make this bigger. Okay. So I've now done this. Okay. So I got my mean, my standard deviation, and my sample size. I want to look at the variances and see if they're comparable by looking at the standard deviation, and then I want to run my t-test. Okay. So the variance of these, oh, I'm in the wrong one. I'm in my desktop version. Okay. This is the unknown. So we look at the standard deviations, they're 134.90. Those are actually a little bit off. So I'm actually going to use option 3 here. You basically can't go wrong by running option 3, but you don't have to run option 3 if the variances are a little bit closer. But because these are really kind of off on the 134.90, those are really kind of like a bit off. So I am going to use method 3. Okay. So now I'm actually going to, I want to make this bigger because I know it's probably not super hard to, a super easy read. So I'm going to make it up here. And now I'm actually going to run the test. Let me actually copy this. So I'm going to copy this and I'm going to put it up here. I'll do paste special values. And these are my summary stats. I probably should have labeled them, but this is F and M. Okay. So now what we want to do is we want to run our null hypothesis is that the weight of females is equal to the weight of males. Okay. That's what we're testing. And so we're going to test it by doing this equals t-test. Okay. Array 1, array 2, type, tails and type. So array 1 is the female weights, array 2 is the male weights. Tails is going to be 2-tail. We're always going to run 2-tail. That's the not equal to. And then we're going to put in a 3 for that. So we need to put it in our column J, which I think it's just going to read column J. It is. And column K is the males. See how it's color highlighting them too? And then I'm going to do a 2-tail distribution. And then I'm going to do 3 for making sure that it's accounting for that not so equal variability. And then it's going to give me a p-value, which is 0.081. So this is my p-value. Probably should have made it a little cleaner, but that's my p-value, which is my ultimate result for the test. Okay. And what that p-value is telling me, now this one is awfully close, is 0.08. But it's not below 0.05. So the p-value is not less than 0.05. So we're going to conclude that there's no difference. No significant difference. Okay. I mean, yeah, there is a difference, but it doesn't reach the statistical significance level that we're looking for. And there you go. That's the p-value method for doing a 2-sample independent means test in Excel. It's not that bad. You can do it. So next we want to do, that was what we just did. We interpreted the output. The p-value was not less than 0.05, so we failed to reject the null that the means are equal and suggest there's no significant difference. Now what I want to do, I did the same thing with the 1-sample test, is I want to look at the alternative way to run this test, which is to use confidence intervals. So with the 2-sample test, what we do is we do a confidence interval for the mean of each group, not for the data overall, for the mean of each group. And then we just look at whether or not the confidence intervals overlap. And if the confidence intervals overlap, there's no significant difference. If the confidence intervals don't overlap, there is. So it's really simple. Again, running confidence intervals came from assignment 10. So I'm not necessarily going to refresh that. It's back in assignment 10, but let's go in and do this confidence interval method. So here, we actually have the same data. So I'm actually going to cheat a little bit and just copy the table that I already have. Okay. And I'm going to just paste it into here. Paste special, values only. And remember that my confidence interval is my mean plus or minus a margin of error, right? And we have right here our means, so we don't need anything else there. Those are our means. What we do need is a margin of error. Now we want a margin of error for each group. So I'm going to do the female margin of error and the male margin of error. Let's do the female one first. Oops, I don't know why I just did that. And the margin of error, remember, comes from this weird formula. It's equals CONFI confidence T. This kind of like looks like it's going to give you a confidence interval, but it's not. It's kind of mislabeled. It should be labeled margin of error formula. At least I think it should be, but it's not. It's labeled confidence formula, and that's not what it's giving you. It's just giving the margin of error. So alpha is 0.05. Okay. And the standard deviation is right here because we're doing one for the females. And then the sample size is 34. That's why we needed these values. So we have the female data, 199 is the mean, 134 is the standard deviation, 34 is the sample size. This is giving us a margin specifically for the females, which is 46.7. Okay. And if we want a margin for the males, let's do that next. This is going to equal confidence.t, and it's going to be at the 0.05 level because we're doing a 95% test. Oops, type B wrong. Okay. And then the standard deviation is here, and then the sample size is here. So I'm coding those in with those. And the margin of error for the males is 44.9. Now, what I do for a confidence interval is I just take the mean and add and subtract the margin of error. So for the females, the low end and the high end, it's going to equal this value here minus the margin of error. That's our confidence interval. Our mean point estimate minus the margin of error is the low end. And then our mean point estimate plus the margin of error is our high end. Again, still for the females. Don't mix the males in yet. Okay. And so we get 152 to 246. Let's do the same thing for the males, the low and the high. But for the males, we're going to use their mean and their standard deviation, not the one for the females. Let me actually just double verify that I got these correct. Yeah, the K ones. Okay. So we have the male margin of error as well. So we have the mean and the margin of error, which is all we need for the confidence intervals, the mean and the margin of error. So this, because we've already calculated the margin of error, is going to equal this value here minus the male margin of error. So it's the male mean minus the male margin of error, 106. And then the high is going to equal the male mean plus the male margin of error. And that gives us this. Now, this interval here for the females, I don't have any like, and then we have this interval here for the males, and they overlap. Okay, can you see that? So 152 to 246 and 106 to 196, like if we plotted these on a number line, they'd overlap. So because the intervals overlap, we can conclude the group means, which in this case is the weight of the females, is not significantly different. In other words, the average weight of females and the average weight of males based on this data even though they're obviously not like the same, there's a lot of variability and stuff going on. And when we account for that, we can't detect that there's any significant difference between the weight of the males and the females. And the confidence interval method should concur with the result from the p-value method. And so that is the basics of how to run a 2-sample means test of independent samples in Excel. And I have for you 2 p-value method ones and then 2 confidence interval method ones. This is data that has 2 groups, so you're gonna do like 2 analysis of this with each group separately. So you're gonna do like, this is gonna be like one set. I probably should have got like, so you can just actually get rid of color when you're doing this one. See how that's gonna work? And then like you can actually get rid of organic when you're doing the color. I did leave them in there, but so hopefully that's not too confusing. Okay, so I think we're all set with running 2-sample independent test. Thanks.